In this video, we will go through some financial maths problems, the most common being compound interest. These can all be done on your calculator using the financial solver. Let's go through the individual parts in the program. N stands for the number of payments. I stands for the yearly interest rate. Whenever you use the financial solver, you must always put in the yearly interest rate. PV stands for the present value, the amount of money you started with. PMT means how many regular payments. FV stands for the future value. What will you have at the end of the problem? PPY is the payments per year. CPY is the compounds per year. If you are compounding the interest yearly, there will be one compound per year. If you are compounding monthly, there will be 12. Payments per year and compounds per year are usually the same. The interest is usually calculated at the end of the problem. You need to be careful in the way you enter information in the financial solver, as it needs to know which way money is flowing. If you receive money or somebody owes you money, enter the value as positive. If you pay out money or you owe somebody money, enter the value as negative. In order to find the financial solver, go to Menu, 8 Finance, 1 Financial Solver. Let's go through some individual problems.
This tutorial video focuses on the basic compounding interest examples. We're using the TI Inspire CAS calculator, particularly using the finance solver function. Example number 1. James invests $2,000 in an interest-bearing account for a period of 2 years. We wish to calculate the account's balance after 2 years, given that the interest is compounding annually at a rate of 9% per annum. Using the financial solver, you'll get a screen that looks like this. First of all, the period is for 2 years. The interest is 9% per annum. The present value, or the starting value, is $2,000. You'll notice it's negative because there's a cash flow away from James to the bank. No additional payments are made. There is only one payment per year because it's annually, and that also generates one compounding period per year, which is annually. Pretty much all financial solver problems will use default setting of payment at the end of the investment period. Finally, we leave the value of the future value we want to calculate blank for our calculator to solve. Let's use the menu, Finance Solver. We'll just delete some of the data that was from the previous examples that have been used and enter it in. So N was for 2 years. The interest was 9% per annum. The finance solver is always looking for per annum with the interest. The principal started at 2,000, and again it's minus or negative because it's a cash flow away from the person, James, to the bank. No additional payments. The future value is what we're trying to solve, and the payment per year is 1, compounding period per year is 1 as well. And down the bottom, payment is at the end. So get our answer, we press enter, and that tells us the answer will be $2,376.20. And so we can see that after 2 years, James's account balance would be $2,376.20. Example number 2. Joanne invests $4,000 in an interest-bearing account for a period of 5 years. We have to calculate the monthly interest rate if Joanne's investment has a balance of $10,000 at the end of the 5-year term, given it is compounded monthly. So we're now not talking annually, we're talking monthly, and our values must reflect this. First of all, the number of terms. It is in months. So it's 12 months per year over 5 years is 60 months. Our present value is $4,000 that's invested by Joanne, and again, it's a negative value because the cash flow flows away from Joanne to the bank. Payment is $0, no additional payments. The future value is $10,000. It is being 12 payments per year. It's a monthly arrangement, and also being compounded at 12 periods per year. Again, to calculate the interest, we leave that blank. Let's head to our calculator. First thing, let's clear our previous calculations. Okay, so for Joanne we had 60 months, an interest we're trying to calculate, a present value of $4,000, no additional payments, a future value of $10,000. Now in this case our payment per year were 12 because it's monthly, and when we press tab that will update our compounding per year to 12 as well. So note our number of terms is 60 periods, 60 months. However, our interest when we press enter will be an annual interest rate, and that's how the finance solver works. So it's 18.47% when we round it per annum. So to get that in a monthly interest rate, we need to divide that 18.47 by 12 for the 12 months, and it comes out to a monthly interest rate of 1.54% per month. Example number 3, Corey needs $6,000 to detail his car. How much we need to initially invest if in 4 years' time is to accumulate sufficient funds. His investment compounds quarterly at a rate of 2% per quarter. So again, it's for 4 years at 4 quarters per year is 16 quarters in total. Our interest rate, whilst it's 2% per quarter, we need to multiply that by 4 because our finance solver is looking for a per annum interest rate, which is 4 lots of 2%, gives us 8% per annum. No additional payments made, our future value of $6,000. Our 4 payments per year because it's quarterly, and also when we press tab that'll give us 4 compounding periods per year, which is quarterly. And to work out our initial value, our present value, we leave that blank. So again, we'll just clear our current data. Let's fill it in for Corey. 16 quarters at an interest rate of 8% per annum, an annual interest rate. We want to know what is our present value, no additional payments, a future value of $6,000, which you note is a positive value because it's money that will come back to Corey. Our payments per year are 4, and when we press tab, that will also update our compounding per year, compounds per year. So we go back to our principal value now. Press enter. Our present value, you see that Corey would need to have invested $4,370 and roughly 67 cents in order to get that $6,000 at the end of the 4-year period. So the initial investment needed, or the principal for Corey, was $4,370.67. Our final example, example 4, is how long will Laura need to invest $5,000 in order to gain a balance of $15,000 in an account that compounds interest weekly at a rate of 0.2% per week. Finance solver, again 0.2% per week. Finance solver needs interest in an annual or a per annum, so 52 weeks multiplied by 0.2 gives us an interest rate of 10.4% per annum. When she's investing $5,000, again, a minus value because there's a cash flow away from Laura to the bank when you invest. No additional payments. Future value of $15,000. 52 payments per week, which gives us also 52 compounding periods per week. And we want to find out what is the term, or how long this will take. Now remember, because this is in 52 payments per week, per year, we're talking weekly, so our number that we get as an answer will also be the number of weeks. So we'd expect a rather large number. We'll clear our current data for the finance solver. So N, we're trying to work out the number of weeks. The interest was 10.4% per annum. The present value was $5,000. Again, it's a negative because it's money going to the bank. No additional payments. We want a future value of $15,000. Payments per year were 52 payments per year because it's weekly, and we tab that and updates the compounding periods per year as well. The number of turns will be 549.86 roughly or rounded, weeks. So, that equates to 549.86 weeks. When you divide by 12, it's roughly 10.5 years. When you multiply the 0.57 by 12 to get it as a whole number of months, it rounds to approximately 10 years and 7 months.